what's the difference between what RPath does and any other tool that I might use to create images? So far we've talked about images, CDs, bootable images, cloud images as being an output from RPath products. Well, the truth is we regard images as actually relatively uninteresting. Images are something you want to build a new system, to deploy a new system, but frankly, images are an output. They're generated, right? They're disposable, or at least they ought to be. The truth is today in the industry, most approaches to producing an image put a real emphasis on the image itself. They basically tell you those images are gold, they're the golden master, and you put all this effort into producing those things, and then you've got to manage images, right? So the emphasis is on the thing that you produce as what you manage. It's analogous to an automotive manufacturer again, actually worrying about the individual cars it produces more than the process whereby it produces them, right? If that was the emphasis, we'd still be handcrafting vehicles on a one-by-one basis. So what RPath does that's uniquely different is we approach the problem of producing images as a problem of defining what should be in the image. We emphasize building a model of all the software elements required to run that system. That model and the fact that we take a model-driven approach is the big difference. Because once you have a model of a system, you can generate anytime you want an image in any format. You can generate an image today for installation on a bare metal box. You can generate an image tomorrow that runs on the Amazon cloud or whatever new platform, whatever new target comes along. So one of the parts about using a model-driven approach is valuable is that the image itself now just becomes a disposable, generated on-demand output. On-demand image generation. And it also means that instead of emphasizing the storage of images, the management of images, we're really talking about the storage and management of the models. We can throw the images away and produce them again anytime we want. It's a little bit analogous to what the manufacturing industry has taught us over the years, which is you don't want to have huge inventories of finished goods. What you want is just-in-time manufacturing. You want to be able to take the blueprint for a vehicle or for any consumer product and make it on demand at the last possible moment to reduce your working capital, reduce your storage, and reduce the risk that what you've built already is out of date. Let's not maintain, an empty lot full of cars that we haven't sold. Let's produce them on demand. So we're all about model-driven system definition, if you want to put it that way. Defining what needs to go in. Think of it like the bill of materials or the blueprint for what it is we're going to produce. Now, a key part of what you've got to do, if you're going to say images are disposable, throw them away, generate them when required, is you've got to be able to get out of this system the exact version of all the parts you want for an old image, for an old system, because you may have audit requirements, you may need to bring up another 500 instances of that particular set of software, because that's what's running in production, even though you've gone on and evolved it in development and evolved it in test. So model-driven alone is not sufficient to solve the overall life cycle problem that the enterprise or the consumer faces. You've got to tie it with version control. This is a lesson that we have learned over and over and over and over again in the software development world. And in fact, today's modern practices of agile, sort of just-in-time development, if you will, that can produce new functional enhancements of products on an incremental month-by-month basis are fundamentally possible because we as software engineers have embraced version control as a foundation. Everything we do when we write code today is predicated around the idea that we can be risky, try things, change things, because we know that we can always go back to a safe spot because we've version controlled everything. That's how we manage change in the software engineering space. The problem is that the way we today put systems together doesn't take advantage of that. And this is again where RPath is unique in that we have tied model-driven definition to focus on what matters, which is the content of the systems, with version control, so that you can manage change from start to finish into the future or into the past.